Okay, welcome back, everyone. So we're ready for our next speaker. Damian Andrew Tamburri is a very interesting speaker. He's based in Italy right now. He's an associate professor at TUE here in Eindhoven, and also at Euronymous Academy of Data Science. His interest and focus is on complex software and data architectures. And he's here today to talk about the RADON framework, which is an EU-funded project to work on basically open source frameworks for creating microservice applications on top of to leverage serverless computing. So very exciting new topic. I think there's going to be a lot of developments in serverless computing. So very eager to hear his thoughts. Now, Damian has requested to show a pre-recorded video. This is because of some potential instability issues in the connection. So we will stream the video currently. However, he is online right now, so he is going to watch the Discord channel on the talk closely for any of the questions that you may have. And also, he will be available for any sort of networking questions regarding maybe job opportunities at TUE or interest of if you're maybe interested in going to study there or doing a PhD. So please reach out to him with any of these kinds of questions as well. So enough talking. Let's get started with the video.
So it looks like the recording is started. So hello everyone. Unfortunately you are not seeing my face, but I'm showing it here now on purpose because as it turns out I have a nice face, but on the other hand you won't see me with a tie and neck noose as often as you might think, in the sense that I'm very much a nerd, so I will welcome your questions after this presentation. So what is the presentation about? I want to tell you a little bit about what you as a data scientist can do in the context of using serverless machine learning operations, and what I have been doing in the scope of a European project called RADON, which has in fact at the core this idea of proposing an endeavor to structure serverless computing in the scope of machine learning pipelines. And without further ado, let me just say a few words about myself. My name is Damian Andrew Tamburri. I'm an associate professor at Eindhoven University of Technology, but I dwell mostly and spend most of my time at YATS, the Euronymous Academy of Data Science, and I'm going to tell you a little bit more about that. Now, for the nerds of you out there, like me, men and women after my own heart, you'll find a nice QR code in the bottom right and an email, so reach out to me or my personal website or professional website in case anything is not clear or anything might inspire your curiosity beyond what we can deal with next week. Because go figure, I'm registering and recording this on October 2nd. All right, so let's go through a bit of a roadmap for today. First of all, I'm going to tell you a little bit about YATS and the Jade Lab, of which I'm the executive head. And then I want to delve deeper into what is this MLOps paradigm for those of you who are not familiar with it, but also what is serverless, what is function as a service, and then I'm going to delve deeper into what we propose and how we propose to address these frameworks and these technology in the scope of the RADON machine learning operations approach. So reflecting this very rich and dense roadmap, let me say a few words about the Euronymous Academy of Data Science. Well, first of all, let me just say that it is an initiative, joint initiative, in fact, from the Eindhoven University of Technology, where I dwell from, and Tilburg University, which is, as some of you might know, a peculiarly Catholic and somewhat old-fashioned university dealing most especially in human and humane and societal and social aspects, not only of computing, but also of society in general. So YATS emerged as a combination of the socio-technical expertise at UVT and the more technical, more hardcore, super theoretical and practical as well expertise at Eindhoven University of Technology. There's been growth on every front, so you see some of the figures here in this slide right here. We have about 300 students with a growth of that number of about 250% yearly, although COVID has in fact taken a lot of that away. So I want to say that number is down to, let's say, more or less 100% growth in the sense that every pre-master period normally gets about 50 to 70 students for the yearly programs. Of course, the total amount that you see in the 289 figure, that reflects the total amount of students which is enrolled between the master's degree, the PDEng programs, and the PhD program. So numbers are in fact thriving, and our activities have been going on since 2016. As you can see, Queen Maximum here herself, she came and opened up the initiative since about 4 years now, in fact. Now, what is the JADE Lab in the context of this? Now, JADE stands for Euronymous Academy Data and Engineering Lab. So at JADE, we address all aspects of software and data engineering research, software-defined infrastructures, and software-defined everything, in fact, as well as applied machine learning research, applied machine learning operations, so what is known as data ops, what is known as ML ops is a part of the recent trend of data ops and what it comes from it. Essentially, we are talking about deploying, continuously refining, and improving machine learning pipelines as they are being evolved with direct feedback from either customers themselves or telemetry from runtime. Now, all of these topics, of course, we are trying to apply in very specific, very impactful problems in areas or domains. I'm reporting the two major ones which we are addressing, so smart industry and crime and society, sustainable societies at that. And I will show you a couple of examples more specifically in the data and smart industry contexts, which specifically in fact reflects the project that I'm going to show you in a bunch of slides. So let me give you just an example of the projects that we are taking care of. So EU Age 2020, RADON, and Sodalite are two of the 7 currently active research projects funded by the European Union in the Horizon 2020 framework program. And both projects, in fact, reflect using large-scale cloud applications either in the scope of serverless computing for the RADON project or in the scope of high-performance computing for the Sodalite project to carry out predictive maintenance and application defect and failure proactive analytics in the scope of large-scale cloud applications. So this is just one example of the projects that we are conducting. If you're interested in knowing more, please reach out to me, throw me a shout out, send me an email, Twitter, whatever you can think of. I'm all open and all out there, ready to welcome whatever you might have to ask. So in the scope of these two specific projects, I chose to focus on RADON because it seems like it is much closer to the endeavors and domain that PyData is in fact targeted at. So I want to specifically stress what we are doing in that direction. So what is RADON? Where does it come from? Well, RADON is a software technologies a research and innovation action in the parlance of Age 2020 project proposals. It is a 30-month project with a value proposition which ranges from providing a DevOps framework that helps the adoption of serverless and function as a service technologies while avoiding the most inhumane problem of vendor lock-in. Now, in that respect, let me just give you a few primers on what DevOps is for those of you who are neophytes in that respect, and also to serverless and FaaS at a later stage. So first off, DevOps, some of you might know this already. So DevOps is really is a menu, is a la carte menu, is a set of practices that essentially accelerate the continuous release and re-release of software components of any kind, which means including AI software. Now, typically these two, dev and ops, used to be two sides of the same coin. And in principle, you would have dev teams later decommissioning the work to ops teams when developers themselves would have finished their prototypical and experimentation and validation work on their own prototypes. And then ops people would put those prototypes into operations with the hope that those prototypes would perform well with the end customers. But recently a trend has been emerging in which a series of practices have been trying to combine these two silos, not only from an organizational perspective. So for example, it is very common nowadays to find what are known as DevOps teams, but also from a technical perspective, with all series of practices to accelerate the creation, the verification, the packaging, the releasing, but also the configuration, the integration, the deployment of whatever software components you might think of. Now, if you draw this world into the world of big data, then you have large-scale data intermixed with DevOps software components. So you can think of all sorts of software components that reflect big data and data-intensive computing. Just to give you a couple of examples here, you find NoSQL databases as opposed to all sorts of compute platforms like Spark, Storm, Flink, Kafka, whatever, Hadoop, or whatever the hell you can think of. All of these obviously have specific challenges, but also specific needs and actors involved. And that's why the trend of DevOps being dedicated to specific big data and data-intensive compute applications has been known or has been coined as data ops. So the operations, the development and operations around data-intensive computing. Now, again, if you contextualize that even further, specifically designing it, for example, in the scope of predictive, proactive, preventive analytics, which harness machine and deep learning or AI software in general, then you would have things like Lambda architecture dedicated to specific machine learning jobs. So a Lambda architecture is, as some of you know already, a typical architecture pattern for big data and data-intensive compute applications, but it can be made to function in the scope of machine learning operations. But from a more classical standpoint, machine learning operations really reflect what you are doing day to day in your data scientific endeavor, in which you have any source of data sources, any set of data sources, and a number of libraries and middleware like PyTorch, Theano, Keras, or TensorFlow, or whatever, or any combination thereof. So this has been known to emerge as ML ops, because again, you have different concerns, different stakeholders, different issues and challenges, and also technical solutions, which reflect anything between the continuity of your deployed model or the automated retraining or active learning of your own model as well. Now comes Serverless computing, what is this serverless computing thing? How does it reflect ML ops? Where is it coming from and where is it going? Well, for those of you who are geeks and nerds like me, you might know this evolution that I'm showing you here now. Indeed, you have things like, originally, you had things like applications being designed for specific bare metal configurations. And then on top of that, you had virtualization, you had hypervisoring, so you had cloud infrastructures that you could use to deploy and continuously operate your applications. But then you came to containers, and how containers changed the world is that they effectively inserted onto the technological market the ability to quickly scale up or down specific applications with their own technical space into containerized, into packaged formats that would allow them to be relocated very, very easily. This architecture pattern was known to be microservices, and that's why this neatly red shaded box around containers bears the mark of micro services. There's all sorts of containerized microservice trends and technologies thereof. You can think of, I don't know, Kubernetes or Docker or whatever is your favorite. There's so many out there. But at the same time, containers themselves and microservices, for that matter, did not really specify the level of granularity to which your own whatever general purpose application was supposed to be designed and operated, and at which level of abstraction that decomposition should have been made. That's where functions come in and where serverless computing really realizes its promise, because functions themselves are essentially fine-grained units of computation which are hosted in the cloud and fully managed by the provider. It doesn't mean that there is no server. Serverless by itself means that you are not supposed to manage anything from the server side. The server is a transparent device to you, the functional programmer, and this also means that you have all sorts of cost savings, that your workloads are event-driven, and also that you are paying for compute cycles. You are paying for whatever function runtime you actually realize. You are not paying for the deployment of a specific work unit or a specific microservice. So even though there is, in fact, architecturally a strong synergy with microservices, there is no restriction from a deployment perspective. Your function is only deployed insofar as it is consuming computational resources. And this provides, for example, in the scope of Amazon Web Services architecture, this provides for all sorts of benefits. From a development perspective, for example, you would run code without servers because you can use all sorts of existing libraries. You can make your own, rotating around specific technologies, but also while you upload your own functions and configure the triggers in an event-driven fashion, for those functions, you forget about managing whatever deployment details and whatever serverless specific continuous infrastructure management considerations you might think of. So let me give you an example of these sort of pipelines or these sort of functional approaches. Imagine the classical extract, transform, load data pipeline. You have all sorts of arrivals of raw data in the data store, and you have all sorts of triggers being triggered by specific data events. So for example, specific types of data are being input, or specific queues are being filled out in the scope of queuing management. So you have all sorts of streaming data coming in. What you as an ETL engineer want to do is take that data in, understand what that data is about and process it in such a way that you come up with enhanced data. Now, what you see also in this domain is a very much transient, very much event-driven pipeline, which features all sorts of analysis, all sorts of annotation, all sorts of enhancements being done in the data pipeline. So how about you actually turn whatever intelligence is taking care of the analysis, those annotations, those enhancements, and you realize that intelligence with a series of serverless functions that are triggered like that by events in the scope of the architecture, but also are rigged to consume the least amount of resources possible. What is the outcome of that? Well, the outcome is quite obvious. You have improved data integration for downstream consumers, but also at the lowest expense possible. So again, imagine implementing this ETL data pipeline featuring all sorts of fine-grained event management, all sorts of continuous and unpredictable load management, and accommodating all sorts of continuous changes in your machine learning pipeline, because keep in mind, you can manage a serverless function just like you would any microservice, in which case you can do all sorts of things like more advanced A/B testing. And if you don't know what A/B testing is, just go and Google it. It's actually quite fun as a deployment testing strategy. But again, there's all sorts of benefits to it. What do you need to make this promise a real thing? And this is where RADON comes in. The conjecture that we have at the basis of the RADON Research and Innovation Action is that you definitely need an integrated IDE, so an integrated development environment with all sorts of full stack end-to-end DevOps support, but also you might need platform agnostic application and machine learning modeling. Why platform agnostic? Because let's face it, you need TensorFlow as much as you need Keras, as much as you need all sorts of other libraries which are out there. So you cannot endure the luxury of vendor lock-in. If you're content with Hadoop MapReduce, which is available on Azure, then go for it. Maybe you are, maybe you're not. I don't know, but if you are going for a complex application which features the exact same characteristics as I've shown you a couple of slides back, then you might desperately be needing platform agnosticism, because you cannot endure the luxury of going back and forth. Now, in the scope of those application and ML modeling, you might also want to ensure quality of your applications. And that is exactly where the flexibility needs to come in, because at the one hand, you have your cost effectiveness, but at the other hand, you want to maintain specific qualities like also security or privacy, or even simply maintenance ability. And that's especially where RADON comes in. We have, in fact, realized an integrated development environment, which is, by the way, web-based and container-oriented. So Eclipse Che is a new spin-off of the well-known Eclipse modeling and software development environment, which integrates all sorts of operations view as well. Now, in that respect, we are obviously supporting a DevOps lifecycle, and let me show you what kind of tools and toys we have been developing for you in the scope of the same challenges and issues that we have been discussing in this slide right here. So in terms of quality assurance or flexibility, and there you have it. So we are providing you with graphical modeling, so you can assemble your infrastructure, your serverless compute application in a plug-and-play fashion, in a drag-and-drop fashion. We have provided you with a series of constructs that allow you to put together this application. I will show you a bit more of that in a second. But also, we want you to reason on how to decompose your application, whether on on the basis of serverless computing, but also, for example, on more more coarse-grained microservices. Also, we want you to run defect prediction on your pipeline, because the more you grow your application, the more your infrastructure code is going to become bigger and bigger and bigger, which means you are making yourself prone to instill defects inside your software code. And at that same level, we want you to conduct software verification and validation, so testing and verification on top of your own solutions. Lastly, from a platform agnosticism perspective, we want to do your reasoning using a technology which is by design platform agnostic. And that is also why we are providing you with a template library, so a series of constructs for deployment of whatever you can think of, whatever application component you can think of, but using a standard for infrastructure code which is not specific to AVS, which is not specific to Ansible, which is not specific to Terraform, which is not specific to Kubernetes, which is not specific to any one technology. And that is, my friends, the Oasis Tosca. Tosca stands for Topology Orchestration Specification for Cloud Applications, and it is in fact a de facto standard for platform agnostic infrastructure code. And that rests me from showing you the integrated development environment with end-to-end DevOps support, which also, by the way, includes all sorts of continuous integration, continuous deployment facilities, as well as all sorts of reusable functions that you might want to reuse and assemble. And I will show you an example in a second. But also, lastly, it includes monitoring facilities based on Prometheus, which itself is an open source solution which is customized to support the RADON IDE. And the idea is that you want to deploy your application even in a quick and dirty manner, but also you want to observe this application in action and learn from that application in such a way that you can, in fact, improve it over time and with telemetry from the actual usage. So let me show you a bunch of these tools in action, because they are, in fact, integrated into the RADON IDE. Let's start from the graphical modeling. This is just a snippet of the graphical modeling environment itself. As you can see, you have a number of components, and on the left-hand side, you have a pane which contains all sorts of constructs that you can drag and drop and assemble. Now, the graphical modeling tool also allows you to produce Tosca-based deployable definitions for whatever you assemble on the left-hand side. Now, I'm leaving links, and I will show you also links during my Q&A session at PyData to show you how you can reach these tools, how you can play around with them for your own large-scale serverless-based data pipelines. So go nuts with them. And by the way, I only have time to show you a couple of tools. So for example, given that you guys are girls are machine learning freaks, just like I am, I want to show you the machine learning intelligence and predictive maintenance features inside the RADON approach, featuring, for example, the defect prediction, which itself essentially is rigged to analyze whatever infrastructure blueprints you come up with after you have used the graphical modeling tool. Essentially, we have been defining a number of infrastructure-specific metrics that you can use to analyze the well-being, the welfare, the healthiness of these infrastructure blueprints. And as a matter of fact, we have a serverless pipeline to support this endeavor as well. This is just a series of details from an architectural perspective. So if you have questions about this, I don't want to delve too deep into the details here. Just make a note of what is happening here. And maybe if you have questions during our Q&A sessions, please do tell. But last but not least, I want to ensure you that from a research perspective and from a machine learning perspective, we are on top of the state of the art in the sense that we are using advanced facilities, for example, for active learning, as much as we are, in fact, using feedback provided by tool owners concerning the metrics themselves, which need themselves validation as well. Last but not least, from a verification perspective, you can think of all sorts of constraints from a privacy and security or, I don't know, even design pattern violations perspective. Now, we have, in fact, implemented a tool for which you can define specific policies that you want your data-intensive pipeline based on serverless computing. You want that pipeline to uphold and support. Inside the verification tool, this is possible. I will also show you an example of this in the next couple of slides. In the scope of the Via Rota smart tourism system, because this system is in fact one of the case studies that we have to conduct as part of RADON. Now, Via Rota in fact is a pretty complex, I want to say, recommendation system for smart tourism. So for example, one of the business scenarios is optimized personalized tour plans, but you might also have all sorts of opinions from customers to points of interest, and you have all sorts of challenges with respect to that. Let's check out one of the models that we have in fact realized for this application. This is one of the topologies. As you can see here, you have all sorts of S3 buckets. All of this is tangled upon Amazon Web Services technology, and it is using Apache NiFi as a middleware for the data pipeline, which is in fact an extract, transform, load pipeline. And as you can see on the left-hand side, there is in fact a public cloud invoking trigger, because at this stage the application is interacting with an OpenFaaS solution, which is stored indoors to the application owner. At the same time, you also have S3 buckets which contain all sorts of data inputs from the external environment. Now, inside the red arrows, you can see, or rather you cannot see, but if you would click on these red arrows, you would see constraints being defined on each of these red arrows and verified via the constraint definition language and the constraints verification tool. That really concludes my talk. So I want to give space for questions, which I presume will take place next week. The last point I want to mention is I'm leaving a number of bibliographic items for you to go crazy about. Some of these reflect some of the concepts that I've talked about or some of the constructs that I've defined. So if there is anything which is not clear, just go crazy with some of these publications. I'm sure that you might be able to clarify your ideas around these. Or on the other hand, if you have questions on any of these, just please let me know in our Q&A session next Tuesday, I want to say, or Wednesday. Yeah, whatever. Next Q&A session for this video, and let's take it from here. All right, so thanks for having me. Thanks for Echtjar for arranging this, and thanks to all you guys, the PyData community. Ciao.